This video walks through the basic setup of the SmartServer IoT. Step number 1 is to understand how the SmartServer IoT is connected to the available network fabric using the embedded configuration UI. Power users may also want to understand how to gain access using the serial console. Let's get started. The SmartServer IoT is built on Ubuntu 16.4 LTS release, also known as Xenial. From the Modesto factory, it is configured to support Zeroconf or mDNS to allow for named host access. This works even in networks that do not include a local DNS server. By default, DHCP is enabled to handle the SmartServer IP address assignment. This is a departure from previous SmartServer generations, which used a known static address. Out of the box, all of these scenarios work for the SmartServer IoT. You could connect directly through an Ethernet cable and configure your PC to be on a known subnet 192.168.1, provided it does not conflict with the SmartServer's 192.168.1.222 address. In the second scenario, there is a router gateway configured to manage IP addresses by DHCP. In this case, your PC and the SmartServer get their addresses from the DHCP server. Finally, in a commercial class network fabric where there is DHCP and DNS servers available, the SmartServer can exist as well. Before starting out, have these things on hand: Category 6 Ethernet drop cable, a USB-A to micro USB cable, a 2 GB thumb drive, flash thumb drive, and also have the following software: a terminal emulator such as PuTTY, an SFTP client application such as WinSCP or CoreFTP. Chrome browser is a good choice. Every once in a while, there are problems with Microsoft Edge when it comes to blocking access due to certificate errors. The label on the back of the SmartServer has essential information you need to know to securely access the SmartServer. Each SmartServer is produced with a unique host name based on a base 36 encoding of its MAC ID. You need to know the default user is Apollo for all SmartServer IoT devices. Each unit comes with a secure random password based on 2 quartets of hexadecimal digits and a random separator. The password is user configurable once you've logged in. You must know that in the first customer shipment there is no facility to recover a lost password. In the 2.50 release and beyond, a 20-second press of the service pin will create a period of 120 seconds for anonymous access so that the password can be changed. Also on the back, you'll find the MAC IDs should you need them. So here we have our minimum benchtop setup for development. We have our SmartServer IoT powered with a 12-volt power supply, a U60 channel adapter attached, and a Category 6 Ethernet drop cable connected to the ETH0 LAN connection of the SmartServer IoT. Windows users need to verify that the Bonjour print services are running so that Zeroconf mDNS can work. iOS and Linux users can jump ahead. Run the Control Panel Programs and Features applet to verify that Bonjour and Bonjour print services are installed, and critical that they are at the exact same revision level, in this case 2.0.2.0. If the revision levels differ, uninstall both programs and reinstall. Find the Bonjour installer by searching Bonjour print services. Near the top of the search results will be Apple's Support and Download Center. Download and install this on your Windows machine. At times, you will need to connect to the serial console of the SmartServer IoT. Consider the case where the SmartServer was configured with a static IP address that you don't know. To do this, start the Windows Device Manager and connect a USB-A to micro USB-B cable between the console port of the SmartServer and your PC. After a short time, FTDI drivers should install. Inspect the ports, COM and LPT to see if a new COM port has shown up. Should this not occur, you need to expand the Universal Serial Bus Controllers branch and find the USB serial converter, right-click on it, look at the Driver Properties Advanced tab, and enable the VCP or Virtual COM port option. Once this is done, the next time the cable is plugged into the PC, you should see a new COM port enumerated. Now I know that my SmartServer IoT can be reached on COM port 3. I'll go ahead, start a PuTTY session, and use the serial interface to connect at 115/200 bits per second. I'll log in as user Apollo and the password that was configured on the back of my Apollo. And from here I can do an ifconfig to learn about the IP address for the connected Ethernet port. Also, if we scroll down to the bottom, you'll see that we've got, on this particular instance, two LAN interfaces attached to the SmartServer, LAN 0 and LAN 1. As a network-connected device, the SmartServer IoT's TCP/IP address is essential to know. Let's enumerate the different networks that might exist. First, in a network with DHCP and DNS enabled, you can reach the SmartServer directly with its host name. If there is no DNS server available, but DHCP is enabled, you may need to engage mDNS and add .local to the host name to reach the SmartServer. With secure certificates enabled and a fully registered name, you will use hostname.echelon.cloud to reach the SmartServer. If you resolve the address by using the console in ifconfig, you may just type in the raw IP address. And finally, in the case where you just connect the SmartServer directly to the PC and put the PC at 192.168.1.x subnet, you can access the SmartServer with its static address, 192.168.1.222. Okay, let's go ahead and get going. We're going to fire up Chrome browser. I actually have a link here to my SmartServer. This is the landing page where we log in using the Apollo credential as marked on the back of the SmartServer. When we first log in, we're going to see the overall system configuration. And you'll see here that it's set up to be in startup mode. It's from this network configuration page that we want to establish exactly how we want to operate this SmartServer. Normally we uncheck startup mode and select between DHCP and static addresses, according to how we want to manage the SmartServer in our internal network. The System Configuration tab gives us access to action buttons that allow us to do housekeeping on the SmartServer IoT. From here we can change the password, reboot the system, restore to factory defaults, generate service pins, and even update the system image. From here we can also see the network interfaces that are attached, and if we're managing an IP70 network extent externally, we have access to the Class A network settings that allow us to set the domain for our IP70 channel. In the Features tab, we can enable the different interfaces to use RNI. RNI stands for Remote Network Interface, or an interface that is attached by IP. It is important to note that with each feature you enable, you need to lock it in by clicking the corresponding Update button. RNI interfaces are ones that are managed with LonWorks 32 interfaces in the Control Panel applet. It's here that we define the ports that are used and whether they're enabled or not. If we're building a large network with an IP852 backbone, we can enable that here, as well as turn on IP852 extent for external app management as well. Finally, in the RS-45 tab, we are able to select which protocols run on the two RS-45 channels and also the characteristics of the serial data. In this video, we have learned how to determine the SmartServer's TCP/IP address so that we can access it over the network. We've also learned how to connect to the console through the serial port. Finally, we took a tour of the configuration pages that are necessary to set up the SmartServer assets that will be used in your networks.